start streaming, and it seems to be like actually start streaming partway through when I think it hasn't started streaming. But I don't know if you can see my subtitles at the bottom on my screen, at least. They're all the way over to the left-hand side, so I don't know if you can see them or not.
3 screens, we can.
Oh, can you? You can see all 3, can you? Oh, there we are. So can you just see one now?
Yeah.
Yep.
Right, that's probably a bit tidy. I think I've shared the whole screen. How's it coming out? Because I've got this stupidly big monitor now.
It's very wide.
Yeah, okay. It might be better if I was to share just this, actually. Share. That might work slightly better. Maybe. I don't know. Maybe it's still massive. Anyway, it doesn't matter. So, yeah, thanks very much for turning up to the remote Knots IoT. This is essentially our first meetup back. Although not really, because we did a special with Laura at the start of the month on Sonic Pi, which was cracking. Normally we would be sponsored by Rebel, but being as they're not paying for the food or the location at the moment, then essentially they're not sponsoring. But I definitely still want to call them out, because when we return to our physical meetups, and obviously prior to the lockdown, then we couldn't have done this meetup without them. So they get an honorary mention anyway. But being as I'm paying, or my company is paying for the Zoom license, and obviously I'm organizing, then that's why I've put my company in the middle there as the main sponsor. But we're also sponsored by JetBrains and Stickers. Stickers make stickers, but nobody's getting those at the moment unless they get posted out, like Tech Nottingham are kindly doing. But JetBrains, they make developer tools for developers like Rider and ReSharper and WebStorm, PHP Storm and stuff like that. And if you were to send out a tweet on the hashtag NotsIoT, then there's a good chance you could win one of their products for 12 months, which is quite nice. So thanks to them for sponsoring. So tonight we've got the excellent Rob Miles and Steve Spencer, and they'll be talking about air quality Azure Functions, Spider Eggs, and ESP8266 with Azure IoT Hub and Cognitive Services. So 2 fab speakers and talks. Next month we've got, where's the comma there? Derek Rufferstoff talking about Tesla coils. That's going to be really cool. We did have him booked in, and Eleanor actually, and funny enough, Steve and Rob as well for the physical meetups, but obviously everything happened. But specifically for Derek's, then that would have been really cool, because high voltage electricity, to watch that demonstrated is always really cool. But he's going to record a video and take questions after his talk. And then Eleanor, she's going to be talking about smart bins. She actually gave that talk at Women in Tech at the start of the year, which was fantastic. So I've managed to persuade her to come and speak with the help of Anna Hacks. So that's cool. And then at the end of the month, we've got .NET Knots as well, with Ian Johnson and Lee Engleston talking about complex systems and augmented reality. So that will be cool as well. And with that, we will switch over to Steve, who's going to be talking about his ESP8266 system that he's got hooked up there, which sounds fab. On to you, Steve.
All right. Let me. Can you see my PowerPoint?
Yep.
So this is me. I'm Steve Spencer, freelance developer consultant, dog's body, basically. Currently working for Rolls-Royce. I blog a lot about the stuff I talk about, so pretty much everything I will be demoing, there's a blog on it. So I'll tweet out when I've got a new one, and you can see them there on my blog. So yeah, there's loads of stuff. So I'm going to talk today. I've got a project I've been playing with the ESP8266, 8266, with MicroPython. Connects to the IoT hub. I'm using Azure Functions, Cognitive Services, and there's loads of demos. So it should be. Actually, it's one of the nice things of doing Zoom is I don't have to move my demo. As Pete could see earlier, it'd be quite tricky to have set all this up in Nottingham. So I'm quite relieved I haven't had a big stressful day of wiring up and getting networks working. So that's one of the positives. So I don't do IoT as a profession. It's just something that interests me. and I did this project a few years back using Raspberry Pi. I had Windows 10 IoT Core talking to Service Bus, and since this was before IoT Hub was a thing, this was before cognitive services was a thing. So it was using the similar technology, but I wanted to get it onto something else. I wanted to learn Python. I wanted to wire into IoT Hub. I wanted to use multiple devices rather than just a single Raspberry Pi that did everything. And I wanted it to be serverless. So that was sort of my goals of my project, was to take what I had before and basically make it better, I think. So the project is, I've got this door which I've built. You press the doorbell, that enables a camera app to allow me to take my picture. We take that picture, pass it to cognitive services that works out whether I'm a person, and if it finds me as a person and it knows me, then it will grant me access, so it'll unlock my door. So that was all basically sending messages down to the device, but I also wanted to be able to read things from the device and send it to IoT Hub. So I also I've got a sensor on my board which reads temperature and humidity, so I'll read that at regular intervals, and then I'll store that data somewhere so they can actually go and monitor it. So this is my little picture. So we have a doorbell, you click it, I've got an 8266 sitting there. It sends a ding dong message to IoT Hub, which then I've got an Azure function which is waiting for messages from IoT Hub. It picks that message up, plonks on the service bus. My app then recognizes the message, turns my camera on, allows me to take my picture. I can then pass that to cognitive services. As soon as it finds me, we send a message, so I can send a cloud to device message straight back to one of the devices. So I tell it to turn the relay on, so the other device picks it up. It then sends the unlock message back, so the door, I can get in. The unlock message back goes all the way to the app. The app then says, okay, I'll hang on for a couple of seconds, and then it sends the off and turns the relay off and locks the door back. So that's my project. And now I'll go through each bit. So actually the ESP8266, if it was, I went to Rob's talk, the one he's doing next, when he did it in Reading, I think, and he was talking about these devices and they sounded really interesting, so I thought I'd have a look. So the nice thing is they're relatively cheap, so £4 a device. They've got built-in Wi-Fi. The boards I've picked also have a built-in power supply, which is a USB connector, which also gives me a COM port, so I can connect to it and communicate with it from a PC. It's got GPIO ports, so I can use it to control things. I can also read sensors and things like that, so it's pretty good. Supports multiple languages, so I was interested in learning Python, so managed to get Python on there, and it's also Arduino compatible, so you've got the toolkit from Arduino will help you to sort of connect up and configure and that sort of thing. So with MicroPython, it's free, which is, I always like things that are free. It's really lean and efficient subset of Python 3, and it's optimized to run on a microcontroller. So it sort of tries to be standard, but there's a set of libraries which are designed for MicroPython and allows it to run in a small code space. And the thing that's important for this project is it sort of supports MQTT. So that's the protocol we need to talk to IoT Hub. So was one of the sort of prerequisites really of using this, making sure I can use this device. So this is what the board looks like. So very similar to the one that Pete showed you. So it's similar family. This is I guess this is a baby brother or baby sister. And it's good because it's got loads of I/O ports on it, so we can configure those up. But you can also configure up as a serial port. It's got an analog digital conversion on. It's got a built-in Wi-Fi, so that squiggly thing at the bottom is your aerial. The little connector at the top is USB, so you've got power built in. So you can buy these boards. So effectively, the bottom part of the board around here, you can buy those as a separate unit. But then you need to power it. You need to a little bit of extra hardware to do the COM port and that sort of thing. So for the cost, it was more cost effective to buy it as a single board like this. It's really easy to use, so it's good. So quick demo now. So we have, let me get rid of Visual Studio, we'll need that later. Oops. I'm just going to have to turn my camera off now. got a slight issue with running multiple cameras, and I will. So can you see my video? Okay, so I've got my camera working. So ESP8266, exactly the same as what we saw on the slide. It's got pins, so it really easily sits into a breadboard or a PCB, whatever. Your aerial, we've got our power and USB serial port, so I can connect to it. Reset button, whatever. So LED there is useful. It's built in. It's connected to one of the GPIO ports, so I can turn that on and off. And I quite often use that as a status, so I can see what's going on. It's Arduino compatible, so I've got the ESP board installed, but I'm actually only going to use this to do the serial monitor. So this board in particular is set up with a web server on. So you can see when it starts, it basically prints out the IP address that we're at. Let me pull that over here. And it was. So this is all running on the board. So I just connect up to it, and what I can do is I can see that blue LED at the bottom. I can turn that off, turn that on, turn it off. So fairly easy. And you can see, because I've got it connected to the serial monitor, when I click it, so all this is tracing that's coming out from the board, so we can see what's happening. So, but that what we can do in here. So I'm just going to switch boards now because this one doesn't have anything running on it. So that one will automatically run with whatever is. I've got it configured so that it runs and starts the web server automatically. This one I have to load it on and run it when I want to use it. So this is really good for debugging. So turn that on. That just reset. I should be, because I've got Python installed. Oh, that's a good start. Let me try and connect to it again. There we are. So we've got the Python prompt. So I can just do print. Oops, well, people could type, wouldn't it? So it's just running Python. So what I can do is I can actually start typing in here. So if I import the GPIO module, and then we can set that up to P equals, and I'm going to use port 4, and I'm going to configure it as an output pin. So we can set each of these pins up as an in or an out. So out will allow me to turn things off. So we've got an LED. Oops, where are we? There. And that's connected to pin 4. So what I can do here is I can do on. Oops. And off. So fairly easy, fairly good. So that's just running Python, the Python prompt. So that's just probably as much as you want to program on here. It's through here. So what we can do, I've got to close this down now because otherwise I won't be able to connect to it. So what we do have, so I've created a little Python program. So as I said, I'm still learning. So fairly straightforward. I've put some traces in there so I can see what's happening. Loops round 10 times half a second each. And what I want to do is be able to get that onto the board. So, there's a nice little program which I've installed called Ampy. What that allows me to do is talk to the board. So I've got to connect up to the port. So that was COM4, and we need to set we need to set the baud rate. What we can do is I can use commands, so I can list. So this will go off and look at the board, and it'll list what's on there. So you can see I've got a number of files. They're all running on the board. What I want to do is I want to get one of those files, so I can just do. So if I take the boot file, and what that will do, that will copy it from the board. Oh no, it doesn't. I haven't given it a file name. So all that's done is echoed it to the screen. So what I can do is if I just type on there, that will then copy it into this folder here. So we can go in, boot.py is there, edit with Notepad, and there's nothing in it. This board doesn't do anything to start with, so it's just the default setting. So what we can do as well is I can do a put. So what do we have in there to put? Let's put flash LED in. So we can put. Oops. So this is now going to take flash LED.py off of my computer and dump it onto the board. So if we do a list now, it should be on there. So there we are, it's there. So I can also get rid of that. So that should delete that. And there we are. So if I wanted to put that program on there to run, I could do that and call it main.py. So if we look at that, that should now say main.py on there. If I reset the board, you can see, oops, I've lost my camera. That was a good demo, wasn't it? So the light's flashing now, so that should flash 10 times and then stop. So let me just get rid of that because I want to be able to show something else. So that's fine, but it's not the best way of debugging it. But so what you can do is you can do run. So I can do run. So I can actually run that program. So it's going to download the Python, run it on the board, and we should see the light flashing. And if you remember the code, I had some outputs in there. So one of the downsides of this approach is you don't see them until the end. So if you try to debug, you can still get output it, but you've got to get it. You'll get it all at the end, and you've got to work out where you got to. So what we could do is let me put it back again. Right, and then we put this back up, serial monitor, and reset the board. And now you can see the LED's flashing and the tracing's coming out straight away. So different ways of running this, depends what you're trying to do. So let me go back to my slides. So, oops, wrong way. So back to the project. So I've got one of the ESP8266 as a doorbell. I have a door. I have a solenoid door bolt, so I need a relay to drive to turn that on and off. So my other 8266 has a relay. Both boards I've got two boards. Both have got the status LED on, and the one that has the doorbell on has also got temperature and humidity sensor. So every 5 seconds, I think I've set it as, we'll read the temperature and we'll read the humidity and push that onto IoT hub, and we'll pick that up with the Azure function later. So that's where we are. I've got a doorbell. What I did do is I bought this nice little kit. So it's got 37 different sensors in there, and they've got these a lot of them are 3-pin, so they fit in a breadboard really easily, and it means I don't have to mess about with finding wires and whatever. So I'm using the temperature and humidity sensor, using the relay, and using the push button. Each one of these is fairly easy to wire up, and the Python code is really easy to talk to them as well. So it's pretty good. And this is how they look with them connected. So I don't know if you saw he tweeted earlier a similar thing with the breadboard. It looks very similar to that. It looks like he's got the same sensor as well. So you've seen the board on the right, the board on the left just has the relay on. The board on the right, that's my push button, and then that's my temperature humidity sensor. So talked about the boards. We'll talk about IoT Hub now. So IoT Hub, if you're not familiar, is a cloud-hosted backend. So it allows you to connect devices together. Really scalable. No, I don't need to deploy anything. I just deploy the service, configure it up, and away we go. So pretty good. It allows me to talk both ways. So I can send messages from the IoT Hub to the device, and the device to the IoT. So really flexible. Each device has its own device ID, has a key that you need. So you authenticate each device. And more importantly, it supports MQTT. So with Python supporting that and IoT supporting it, means we can talk together. So pretty good. Then we talk the Azure function. So I talked about serverless. So the IoT Hub serverless, Azure Functions are serverless. So I've written a bit of C#, deployed it to a function. It runs in Azure App Service. And the beauty with these functions is the code is really simple because it uses bindings. So I've got an IoT trigger binding. So every time I don't have to worry about the code to connect to IoT Hub, I just add the binding, add some config, it goes away. And every time there's a message on IoT Hub, my function will get triggered and run the code. I've also got two output bound. I've got a service bus output binding, which means I create a message and it automatically gets put on service bus. And I've got a return binding for the Azure storage. So I basically populate a class with some data, and when the function's finished, the data will automatically get stored into storage. So I've got three things, which mean I've probably got half a dozen lines of code, maybe a bit more. So I think the thing that amazed me this when I've done it all was there isn't a lot of code in this at all, and it's pretty easy to do. So I like it when it's easy and there's not much to do. So that's all pretty good. So finally, I guess is cognitive services. So I was looking at with my previous project. I used cognitive services before it's called cognitive services. It was called Project Oxford, and the nice thing about it is somebody else has done all the hard work for machine learning. So it's an API for artificial intelligence that I can use without having to know how to do all the hard stuff. So they've built a whole set of family of different APIs. So there's a decision API, the vision one, which is one I'm using, the speech one. So we're using image recognition, but the speech one also does speaker recognition. So I could wire a mic up and record my voice, and it does a similar thing. The language one's pretty cool. It will interpret what you've written, or oops, just had on my button. It'll interpret what you've written, or it'll use speech to text and then interpret that, and you can then perform actions on it. It's pretty powerful. But as I said, I'm using the vision one, and that's made up of a lot of different APIs. Face API is one particular one. So the way that this works is you pass an image into it, and it will detect faces, and then it will do a lot of analysis on there. So it will give you like a rectangle of where the face is. So if it's got a picture with a lot of people on, you'll get lots of different rectangles of where it thinks all the faces are. It can do emotion recognition. It can try and predict your sex. It sort of tries to predict your age, but I guess some people probably don't. Some people would appreciate the age guess, and sort of other people wouldn't. And there's a whole load of stuff. I think it can detect whether you're wearing glasses, whether you've got a moustache, facial hair, that sort of thing. once you've got that, you then pass that set of data into a verification engine, and that will then look at each one of those faces and determine whether that is somebody that it knows about, and then that will allow you to detect whether that's the right person or not. So to use a verification engine, you need to train it. So the way you do that is you get a whole load of photos of the people you want to verify, and pass them in and train it. And every time you need somebody new to you want to add somebody new in, you'll need to train for that person. What you'll get back is it'll say whether it's got any matches, and it'll give you a confidence score. So I'm looking at anything above 50% in mine as a fairly good confidence that the person is who they say they are, but it does give false positives. So when I set this up originally, I set it up for me and my wife, so we could both, it would work for both of us. And then when my daughter tried it, it let her in, which was a bit confusing. So she was sort of laughing at me then. So I did a bit of research, and unfortunately for her, it wasn't me that she matched with. It was a mother. So I couldn't really rub that in too much. But what it did sort of say that I needed to sort of maybe look at the confidence score a bit more. At that point, I was just saying it was a match, but it may have been a low score. So all I did was take one picture of my daughter, train it with that, and then when we ran it the next time, it didn't recognize her as my wife, so I didn't let her in. So it is worth thinking about that. There's information in there, you need to use it. So that's why I also put the 50% check in to make sure that anything above that was I would be fairly confident with. So we'll do a demo now. So I'll show you how the Python code and how I connect to IoT Hub. We'll have a quick look at IoT Hub. There's not much to see, but I'll show you anyway. Show you the Azure function. We'll talk about temperature and humidity, and then I'll show you opening my door. So actually, we'll start with not that. We'll start with a Python. So I've got a bit of Python here, which I've which took me a while to work out, and some of it did. It was a bit the connecting up to IoT Hub took a bit, and I've blogged about this because a few bits in there that were quite. Let me just tell me. I can't enter a password and talk at the same time. I'm afraid. So just give me. So the first thing we've done is exactly like I did with my flash LED. I'm setting up the GPIO. So I've got the status LED. So that was the white one that you saw flashing on my flash LED demo. The blue LED is pin 2, so that's the blue one that's built on the board. I've got my my temperature and humidity sensor, and then I have my button. So I'm actually using on the board with the relay. The status LED is also the status of the relay, so they're both connected together. I've put all my config in a file. I load that in, so I get the client ID, password. I need to sort out connecting to Wi-Fi, so I need my password and my SSID. And I've also got a flag to say whether I'm measuring temperature, because I'm using the same code on both boards. I didn't want the relay board to keep trying to read temperature it doesn't have, so I just got a flag in there. And then it's setting up things like I need somewhere to send the messages to the hub, IoT Hub. So you need your client ID and the path. And the first thing I do is connect to my Wi-Fi. When that's connected, that's fairly straightforward. It's built-in network library to do that. When it connects up, I then just flash that LED. So the status LED, which is the big white one, 4 times, so you'll see that. And then I try and connect up. So I've connected to the Wi-Fi. I'm now going to connect up to the IoT Hub. So again, this is a bit that took a while to work out. So we need to use SSL. So for that, you need a certificate. So I have to download that and open it up and load it to the board so that it can be passed through. You set the parameters up with that. The username is a combination of the name of the hub and along your client ID. And I've had to create because I don't have a mechanism for generating a HMAC on the board. I've created an Azure function which I just basically go and call into to generate a HMAC for my device. And then I will just wire that up and fire it all into the MQTT client. That takes a while to connect. Once it's connected, I'll flash the LED, the blue LED this time. But I need to tell it what to do when I get a message. So when you're sending a message to the device, you'll have the light LED. I'll come to that. We do the connect up. I need to also subscribe for messages that I want to receive. So again, we've got a path. So once it's subscribed and the message comes in, the light LED function will call, and all that is doing is it's going to look at the message. So I've got an on message. It turns the status LED on. I'm going to then send a message back to say it was unlocked. So if you remember from my slides, the camera app is waiting for that message, and it will then tell it to lock itself after a couple of seconds, and then I just publish that out onto the IoT hub. So fairly simple. And then so that's setup complete. All I'm doing now is I'm going around a loop. So every 5 seconds, I'm checking the temperature, and I'm going to read the temperature from the board. So really easy. I just call sensor.measure. That has a temperature and a humidity. So all I'm doing is passing that in a message and publishing that on the IoT hub. So it's got a message name of temp, humidity, and the properties are there. And then what I do is these two bits here basically for keeping the connection alive and getting the next set of messages on from hub. So if the message is there, I'll go and call the callback. When that's all done, I then go and just check the value of the button. If the button's pressed, I'll put the ding dong message on IoT hub, publish it, and again we'll just flash a few LEDs. And I've turned the status LED on, so it's at least I know the button's been pressed. Without that, it was not obvious that I'd pressed the button, because you have to. It's waiting for this loop to finish. So sometimes if you time it wrong, you won't quite get the button pressed in the time. So I need to do a bit of sort of tweaking of it to make it more efficient. But having the LED on, at least that gives me that flexibility to know that I've done it, shall we say. Okay, what we need now is the IoT hub. So it does help if I signed into the correct Azure.
I can't see your browser, by the way.
I know.
Steve, just think,
I forgot to sign in before I started, so
that's all right, because it would have signed you out in 5 seconds anyway, because you're doing a demo.
Yeah, it would have done actually. There we are. Actually, I'll wait for it to come up because you're videoing this, aren't you? So I don't want my whole subscription public.
Now you wish you'd created a whole new dashboard.
Yeah, I know. Never mind.
2020 hindsight.
Yeah, it doesn't matter. It's only a test one anyway, so I can delete it. So this is my IoT hub. The main bit I'm interested in is this devices section. So what this is doing is it's looking at all the devices that I've got configured that have connected, and I've got a number of them. The ones I've got are this one. So this has, let me just put that over here so we can see and get rid of that. So we should be able to see my camera again. Yeah. So that's my device ID. I'm not going to show this, but that's my primary key. So that's on the config file that's on this device. I need to run. Let me just remove that. And I need to run the Python that I just showed you. Oh, that's interesting. Let's put the light on. So if we do run, I'm just going to reset this before I do that, just to make sure. So what we'll see here is this should flash. That's connected to Wi-Fi. That LED's come on. So now it's trying to connect to IoT hub. So when that flashes, that means it's connected. There we are. And now in 5 seconds, it should go and do another flash of I'm reading the sensor. There we are. So that's read the sensor for the first time. So now it's in that loop of every 5 seconds, it's going to do something. So we'll go back to here. So what we can do is I can send a message to this device. So I can go on. So if you remember in the code, it was looking for the on message. So I can send that. So that's basically connected through, send it over an MQTT message, and the devices pick that up and trigger it. So suddenly, if I do off, I can send that message, and it turns that message off, turns that off. So pretty useful. I don't really use this for much anything else apart from setting up and just doing some basic testing. There's a whole load of other stuff which I'm not using, which I won't go into. But what I have been using is the Visual Studio Code, because it's got an IoT hub extension, which is really, really useful. So you see, these are all the devices. Interesting why it's only picking up one of them as active, because I've got 2 active at the moment. But so again, I should be able to do the same thing on here. It's a send cloud to device message. So I can do on, and again I can do to off. So that's pretty useful. What I can also do on here is I can monitor in the endpoint. So this is actually connected to the IoT hub, and it's going to read data that's coming back. So what I'm trying to do here is pick up the temperature and humidity sensor info. So you can see temperature 25, humidity 58. Let me get rid of that. And every 5 seconds, it should send me a new one through. So there we are. It's coming through. 12 seconds. So if I just give a blow into this, what we should see is the humidity go up. So it's 59 at the moment, 72. Just go dropping back down again. So just so that it show it's reading it's live data. So that's streaming that data through now. So every 5 seconds it's coming through. I can monitor in here. Let's stop monitoring that. So the next part, we want some code. So Azure Functions now. Again, really simple. I've created a default function in Visual Studio, and then I've added some properties. So I've added a return attribute, and this basically says the data that you return, I'm going to store it in a table in Azure Storage, and the connections in the connection string in settings. I've got another attribute here, which is my IoT hub trigger. So this is basically saying I'm going to connect to the IoT hub, whatever's in that under that configuration setting, and when we get a message on that message's events, we will then return that as a message, the message object, and then I have a final attribute here, which is an out parameter of the queue message. So if I set the queue message, it will then push a message onto the service bus. So first bit is I'm getting the message arrives, the trigger's triggered, I get the data off and basically just deserialize it into a dictionary. There's some basic properties on there which I can use. So I'm getting the device ID, but all I'm doing is getting the message out and looking at it. So if you remember in the code, so if we look at where's it gone there, we should see that the message is temp humidity. So it's pulling this data into a dictionary. So all I'm doing is I'm taking if it's got a humidity, set the variable, the parameter is humidity, set the temperature, you get the time that's on the message, the device ID. Because it's storage, table storage, you need a partition key and the row key. So I'm using device ID as a partition key. So every message, every bit of data related to this device will be in that partition. And then I'm just going to do a row key of effectively device ID and time. So the partition key and row key are a unique identifier in table storage. So I can do queries. I can do a query across the partition to get everything related to this device if I wanted to. And then all I'm doing is putting the data in. Because I've set that, it's returning. That will get pushed straight into table storage. So the code to write to a table storage is pretty much that bit of code. If I didn't have multiple messages, you would just effectively deserialize it, get the data out, and do it and return. If it's one of the other two messages, then I'm going to go. If it's the ding dong message, I'm just going to create a queue message called ding dong, and that's it. Don't need to do anything else because it's an out parameter. It will automatically put ding dong on the service bus. Similarly, I put opened on the service bus when it's unlocked, and I just return null. And returning null means that it won't put any data in table storage. So I've managed to get two different ways of using this without, because I've set, if you notice up here somewhere, I set queue message to null there. If it goes down this path, it won't send a message on the queue. Because I'm returning null here, it won't add anything to table storage there. So I'll get two ways of doing this. It's pretty good. And that's it. So that's my function. So the code, it's a few more than 6, but if you're taking these in as individual items, it is pretty simple to use. So we can have a quick look. Oh no, we can't. There's nothing in there. I've not run this yet. So at the moment, my device has been running, chucking data out into the IoT hub. It's not actually gone put anywhere yet. It's still sat in a queue. So as soon as I run this, it will then pick all those messages up and push them into table storage. We'll look now at the code for the face recognition. So the first thing I need to do with this is I need to train up. We create a face client. We've got the credentials in a key, and fairly easy. You just need to create the client and use it. So so to train this up, I have a set of images. So that's not in there, it's in here. So set of images. So I've got, was it 5 or 6 images of me? So me, various different. These are the test. For some reason, these ones I tested. So number of different pictures. I did my nephew in. I won't show you his picture because he won't appreciate being on Facebook on YouTube. And all I've done there is I've taken the images and I've created 2 lists. What you need to do is create a person group, and the first thing I'm doing is every time I train it, I'm going to delete what was there before, just so I don't get. It's easier than you could just add to what you've already got, but because I wanted to make sure that if I wanted to add extra pictures for me, I didn't have to remember. So I just deleted everything. So it's going around anything that exists already, it deletes them. I then create a new person group. So it's the same person group ID as I used before. And then for each set of pictures, you create a person, and then you go through and add each of the pictures in for that person. So you go through, do all that. So I mean, I've only got 2 people, so 7 different sets of photos get loaded, and then you need to train. So you go into the person group and train it. It's asynchronous, so even though that's returned, it still hasn't finished. So you need to go around and wait for it. You'll get the training status, and when it's finished, when it's succeeded, you can that's when it's done. So it's the first part. So the second part is I now need to do face recognition. So using the same client that I did before. So I've got a bit of code here, which is pulling the image from the camera. I then save it to a file, and I stream that file out. So, oops. All that's doing is it's taking that file and doing the detect. So what that's looking for is faces. So the first part is detecting faces. So if I put a picture with 10 images in, with 10 people in, you would get a list of 10 people back. But I'm only going to take a picture of me, so I'll use my webcam. It should only ever return 1. Once you've got a set of faces found, I then pull the face IDs out, and then I pass that into the identify. So again, same client, and what that does is it will return a set of matches. Now, the first time I did this, I just used, if I had a match, then take that as accepted. But now I've put this confidence factor in, so I'm actually going through all the images, all the matches it's got, and say, are we confident, greater than 50% confident that this person is Steve, or this person is Oscar? If it is, then I've got a match, and then we do some code to send messages to the IoT hub. So again, I'm just sending the messages down using the IoT client back to turn. So this is one's turning the relay on, and this was turning. Remember, I pressed the button on my device and turned the light on, so I know I've pressed the button. This second one's turning that off, so I know what's gone, and then it's resetting. It's resetting my app back to being idle. So shall we run this? I'll get rid of this code. Hopefully it doesn't break. And what we'll do is I'll make a bit of space. Oops, it has broke. That's annoying. No, it hasn't. No, it hasn't. It's just loading up, isn't it? Give me a chance to load my video up. So I've got two devices here. The camera's back to front, so I'm really struggling to get there. We are. So on the left is the relay. We've got temperature sensor, and we've got the button, and then I've got LED there, and an LED here. So when this LED is on, it should trigger my door. So I did say I had a door, and I'll just try and show you. I don't know if you can see. Oops, there we are. I've got a door. Look at that. Also got on the back, I've got my solenoid, so it's connected through that wire, goes all the way back to my relay. So let's put that there. Can we see that? Not quite. There we are. So you should be able to see when this gets triggered. So whilst that was running, the function ran, and I don't know if you can see, it found loads and loads and loads of messages for some reason. So that's because this device has been running. So you can see it's picking up again 25, 58. If I go to my table storage and do a refresh, there should be loads of data in there now. So can I sort by humidity? Yes. So these, you can see this is the ones where I blew into it, so the humidity went up. See what timestamp. So pretty much everything is really easy to use. So that's in table storage. So that's running. You'll see this going around in the background. And then with my brilliant UI design, I've done a camera app. So what I'm going to do is I'm going to press the button. This is where I need multiple cameras. You can't see this now. So I press the button. The LED is on. There's my camera. So that's received. So that's the message that's come through on the service bus. So let me just have a refresh for you so you can see. So I press the button. It's gone through the Azure function. It's put the ding dong on the service bus, and it's gone all the way through to the app. So the app's now turn the camera on. And this is where it gets complicated because I've got a camera over here, which is on a different computer. So I've got three. This is why. So I've got to look at that and press this button at the same time. So let's hope this works. So has it found it yet? Oh, it's frozen. It's got a match. So hopefully you can see the door go. So the door's unlocked. So I should be able to open that now. I've got that message come back to turn the camera off. It's reset and the door's just locked back. So if I shut that now, I can't do it. Wow, that worked. I was pleased with that. So
there's claps in the people reacting with claps. That's good.
Thank you. Right, should we stop demos now, just in case everything's worked? So
you've reached peak demo.
Yeah. So this is it really. So I've shown you the 8266 on MicroPython, and I hope you agree with me that it's really a real cool device, really easy to use. It's powerful for what it is as well. For the £4, and you've got this thing that's got Wi-Fi on and can do all the stuff I've just shown is pretty cool. I've connected to IoT Hub, and I've sent messages directly to the device. And with IoT Hub and Azure Functions, I've not got anything, no server stuff, so it's all serverless. And the function stuff, again, pretty cool technology, really easy to use, really simple. As you saw, there's very little code in there. And then cognitive services just makes it a bit nice and easy to use to do face recognition. So that's it. So thank you for listening. If anyone's got any questions, whatever happens now.
Yeah, thank you very much, Steve. That's awesome. Good timing too. Yeah. So.
Oh wow.
Yeah. If anybody's got any questions,
I shall put my camera back on. Actually.
Yeah, good to see you then. You say all this goes on GitHub, is it?
No, but I can probably put it up there at some point.
Yeah, you should do that. Because I want to see how you've done the IoT Hub side.
It's actually most of it's on my blog actually.
Okay.
So the IoT Hub and the 8266 code should all be on my blog.
Okay.
The face recognition stuff I haven't put up there, but that's pretty much standard code I've copied off Microsoft's website anyway. So
I'm going to find your blog and paste it in the.
It's there. Look at the bottom. I'm not sharing. I'm not sharing anymore. Anyway, I'll put it back up.
Is it? Oh yeah.
Blogs.regnex.org or net or.
Yeah, I've got it. There we go. Awesome. I'm just looking at that processing data from IoT Hub and Azure Functions. Yeah, perfect. That's good. So people can go and check that out. Oh, yep. I see. There it is.
There's a number of different ones for different parts. I think I can't remember exactly what I've done now, but most of it's up there. The whole stuff about connected to IoT Hub's definitely up there because that was the bit that was complicated. So I've got that. I blogged about that. So
sounds sensible. So the Python 3 version that's on there, is that limited in any way, or is it?
I don't know. I'm not an expert on Python, so I've been able to do everything I need.
Yeah.
I've had to use. I think the library, the modules are different. They're like JSON and whatever. So they're similar. So I don't think you can port Python 3 straight over. I think you'll have a few changes, but
Okay.
I think that the Python itself will be the same. It'll more like the imports will be different, I think.
Right.
And I can see Rob nodding his head, so I must be saying something right.
You're right. Have you used Thonny, or there's a PyMaker plugin for Visual Studio Code that you put the programs into the 8266 straight from the IDE?
Oh no,
Oh,
yeah, no, I've not used that. I've just been using Ampy to get.
Good. There's a nice free program called Thonny, which is a complete Python IDE, which will deploy to your device over REPL. And there's also a plugin called PyMaker, I think, which I'll put some links up to, which is a plugin for Visual Studio, which does the same thing. And you can view the files and then just save to it. And that's quite easy to use. But I like MicroPython a lot. It's a great place to work.
I've not tried it. I do need to try it. You get Thonny as default with the Raspberry Pi. I wonder, can
it's
you
the same
program
thing.
Is it?
It's the same tool. Yeah.
Can you use that same tool from the Pi to program the 8266? Will it let you do that?
Yeah, I'm sure you can do, because it's just a serial interface.
Yeah, I mean, you plug the USB in to your Pi, it should just work.
Awesome. That'll be quite cool.
Yeah, because it's just a COM port that's connected up. So
yeah, I like it. Have
There's
you seen
even a UPIP, which you can use to install applications like UMQTT, the MQTT one, and just bring it straight into your 8266.
That's pretty cool.
Cool.
I see on a slightly related thread that MS MakeCode has now got a Python mode as well for the microbit. In case you're interested in the microbit, there's you can do JavaScript already, but now you can do Python as well, which I think is a great idea. So yeah, Python's cool. I did a cognitive services app and a Pi Zero with Python. Actually, I did quite like Python. Apart from having to tab to mean things, I don't like that. But other than that, it's quite approachable. Has anybody else got any other questions? Oh, silence. I don't know if you're all there getting really annoyed because you can't unmute yourself, actually. So I think maybe if I select the unmute yourself button, then maybe that would help. Everyone's really annoyed. Oh, I can't speak. That means let me speak. But nobody else is unmuting themselves at the moment. Obviously, if you've got questions, then do feel free to put them in the chat or unmute yourself and just ask them. But obviously, in the meantime, we'll probably take a 5 or so minute break, and you can go and visit the loo if you need to, and grab yourself a drink. And then at 8 o'clock rather, we'll get going with Rob's talk.
Got a quick question.
Oh, go ahead. Yep.
How are you connecting to the COM port? Is that just a USB to a COM
Well,
port?
the device I've got is got that. The thing that powers it is USB. So that's just plugged directly into my laptop, so it comes up as COM4. So it's got a serial port built in. So that's why I like this device. It's got serial port, it's got power, it's got Wi-Fi. It's like, I don't need anything else. I don't need to do any hardware or anything. It's just plug it in.
So it wasn't sort of wiring off the GPO.
No.
Things
Yeah, that because I did originally. I looked at the board that was just the chip with the Wi-Fi, and then you need to do all that yourself then. So this one was like, I mean, it's £4, so you can't really go wrong.
The only slight issue you can have is your USB drivers for the serial converter on the ESP8266 might not be installed when you plug it in. So you can have fun and games sometimes finding the drivers for them. But apart from that, it should just work.
It's FTDD or FTTD or something like that, isn't it?
It's FTDD. There's also CH430 or something. There's another one which is very common.
Yeah, I think that's the one that Windows gave me, was CH1.
I think mine just worked.
Yeah, it did just work for me.
Most of them do.
Yeah.
It used to be a problem with the Arduino clones, the Uno clones as well, didn't it? Until they open sourced all of that and solved that problem.
You used to use knockoff versions of the USB chip.
Yeah, exactly. There used to be a lot of problems with that, but yeah, thankfully, I think that problem's pretty much solved these days. I know if you're doing, because I've been doing that recently with these devices, and if you can see those, the JTAG hardware debugger. So debugging anything with a an Arduino is often quite difficult. There are packages out there that promise to give you some level of debugging, and I know Virtual Micro will let you have 3 breakpoints or something, but I couldn't get any reading of local variable values and things like that. But a JTAG debugger will give you that, and they just get wired up to the there's on the ESP32 at least there's another COM port, and it does it all via serial. But yeah, then you have fun and games with COM port serial drivers and stuff for the JTAG debugger. You have to start replacing them, but yeah, generally you just plug and play and off they go. It's not too bad. Oh, everyone's so quiet.
I did have a quick question, if
yeah, go ahead, Tom.
possible. Yeah, sorry, you might. I actually got a phone call halfway through that, so apologies if you've already covered it. But the MicroPython thing, what's the overhead like that on that? Is that quite? Because if I saw it, it's actually running a Python interpreter all the time.
Yeah.
You're typing in through COM. That's quite exciting. But does that not take a huge amount of resource on the USB?
On the USB, no.
On the ESP.
ESP, yeah. I mean, I've not had any issues with it in speed, but I'm not doing a lot of complex stuff on it.
Does it tell you how much free space you've got left? I know when you do a standard Arduino upload, it tells you how much flash space you've used. But
and I'm not using it. It's not flashing it, is it? It's just copying the files over. So
there's all this Python garbage collection stuff is actually available to you, I think, in MicroPython. So you can find out how much of resource you've got left as it's running.
right.
In my experience, as Steve says, it's fast enough for what you'd want, unless you're doing things like producing audio on the fly or something like that.
Okay.
Because it might be tricky.
yeah, I mean that was the other reason why I wanted multiple devices, because the code is fairly simple. Then I can do, because they're cheap, I don't need to worry about getting everything into one thing and doing lots.
Yeah.
But yeah, I've not had any. I mean, I've not noticed anything slow.
Yeah, I'd not. I'd sort of suspected that MicroPython would be not as good as you've just shown it to be, frankly.
Okay.
It looks amazing.
Yeah, no, it's pretty cool.
It does, yeah, that's ace. Quality. Oh, thanks for that.
Good, thanks.
What was involved in you getting MicroPython onto the 8266? I can't remember if you said that during the talk.
I didn't. I forgot.
Can't remember everything. Come on.
No, it's. I have blogged about it. It's dead easy. You download the binaries, and there's a Python script you run, which just you tell it you comport and baud rate, whatever, and it just does it. That's the beauty with this board, is it sorts all the flashing out for you. You don't need to. So some of the other boards I looked at, you need to like hold a pin down to certain to earth or whatever to get it into programming mode. This one does it for you. So it was really easy. Because some of the other boards I've managed to brick them because I didn't get the hardware bits right.
Oh, really? In what way brick?
Well, put it this way, I can't get them to work, and I gave up. I gave up and bought these, and these I've not had any problems with. So I haven't bothered going back to them because I think they were like a couple of quid each. So
yeah, what's the point?
Yeah, it was like
your own time's worth more than that. Just order more.
Yeah, I could probably get if I could be bothered to spend time looking at it, I could probably fix it. But yeah, these were so much easiasier. I go for easy.
Yeah,
if I can.
Why waste your time?
Yeah.
Have you tried ordering 8266s from places like AliExpress and stuff?
No, I just got mine from Amazon. But actually, did I get them from Amazon? Yeah, I did. I got them from Amazon. But I think if I was buying them in bulk, then I might look somewhere else. For...
White batteries. I'll go and get them. You can do it for me. Cool. My daughter's come in, decided she needs batteries at this particular moment in time. Bless her. Mummy will do that. AAA batteries. I had to go and buy, I took it off Amazon, go and buy a load of AAA batteries. Since lockdown has increased the amount of batteries we need to be buying. They're in the back in the lounge. Good. Right. Well, I'm going to go and use the loo for a minute, and then we'll come back and we'll continue with Rob's talk. So back shortly. Okie dokie then. Thanks again to Steve. That was awesome. Really cool to see 8266. As you said, I spent a bit of time since I realised that how cool it was, and Steve coming on to talk, having a look at that. So it's cool to see the Python version of far prettier to look at than see. Jeez. But yeah, we'll move on now, and Rob's going to talk about well, air quality and spider eggs. So awesome. Thank you very much.
Okay. Right, can you all see that? Can I all see that? Okay, so got it. Speak clearly. I'm using this caption thing, which looks awesome. My name's Rob Miles. I'm going to talk. There's a bit of overlap actually, which is not a bad thing with the stuff that Steve's been talking about. So I'm going to. He's done the first 50 slides of mine, but I've got another 50, so it's okay. Don't worry, the doors are all locked. I know you're already at home. Yeah, quick word about me, about equality, about how you measure it, device building, MQTT, Azure IoT, which is basically a bit of a rehash. And then we look at LoRa, which is great fun and something which you should all know about. And it's called it LoRa, which is nice. Tell Laura I love her in the captions, which is fantastic. About me, I spent a long time at University of Hull teaching computer science. I was in charge of twisting minds and crushing dreams. I'm an MVP. I blog at robmiles.com. I tweet at @robmiles, and I always plug my books. So here you go. That's my Begin to Code with C# book, which has got one glowing customer review. Thanks so much, Mum. Then I move on to my Begin to Code with Python, which I got more of the family involved this time, but some of them weren't quite as reliable as my mum is. So you can use those to learn those two languages. I'm writing one, even as we speak, Begin to Code with JavaScript is being written. And if you want to follow my progress, I'm reading out every single chapter that I'm writing for reasons best known to me. So you can go on to robmiles.com/JS podcast. It's also on iTunes or Apple Podcasts, and you can actually relive the magic of the draft of the copy of the Legend of the Enigma of the Mystery, which is my book, and it's catchy. It's keeping up. The text is keeping up. I'm very impressed. So I shall keep going relentlessly. I want to talk about air quality because I breathe. Everybody here, I think, breathes, and it's becoming an important thing. It's being brought into sharp focus by the COVID thing. There's been a strong correlation between areas of poor air quality and people who've had bad outcomes with the coronavirus. So we have these measuring things that measure air quality, but they're all based on models and actual predictions based on interpolating readings. There's not a lot of local reading going on if you look closely. And so you do take readings at certain points in the country and at certain times of the day, but you don't read very often, and you don't actually read very many. And then you average these things out and use what you know about the emissions levels to try and predict what air quality will be. We thought when we were getting into this in Hull that it might be a fun thing to do to actually try and build some sensors and see what we could find out. And a lot of this, it's all about the fun being in the journey, in the actually making things is a fun thing to do. And it's turned out to be very interesting. If you want to talk about air quality, then you talk about levels of pollutants and also chemicals like nitrogen oxide and ozone, which are very bad for you. Now, those sensors are really hard to get hold of and quite expensive and consume a lot of power. So we thought we'd go with these guys, which are the 2.5 micron particles, because these you can get sensors for. And so these are the guidelines for the number of particles per cubic meter that equate to the various levels of good to very unhealthy. And so we thought we'd actually start measuring air particle densities using sensors you can buy. And what we're looking at is, there's a human hair, not one of mine. All mine are blonde. I tell myself. Particles of sand. These are the 10 micron particles, and orbiting them almost exactly a quarter the size, one would have thought, of the 2.5 micron particles. Now, these are nasty. A micron, by the way, is a millionth of a meter. That's an extremely small particle. And the problem with these guys is that they can get into your blood and travel round and lodge in organs and cause all kinds of trouble. And so that's what we thought we'd look at. And I've moved on to my mission statement, stroke statement of purpose, which I go for. I think we can use tech to try and change the way people behave, because if you make people more aware of the damage they're doing, there's a good chance they'll do things about it. People don't use plastic bags anymore, and people that let their dogs poo on the street are frowned upon in polite society. That's changed because of social changes. In the olden days, there was open season on both of those. If we produce evidence that people's behavior is generating this stuff, then maybe the people will start to change what they do. And I'm quite keen on this, and I think it's a good starting point. It's a good kicker. And also, if you want to learn something, try and build something. I mean, Steve's door lock is an absolute case in point. I want to learn about IoT. I want to learn about how to make stuff look in Python using MQTT. I know I'll make a lock that opens to my face and nobody else's. So if you have a purpose, if you have a thing you want to build, just saying, I want to learn about MicroPython and how I can control things with it, fine. But a remote control cat flap, or a thing that tells you the garage door's still open, or a thing for your prize marrow temperature readings, build one of those, because you know what you want and you get a happy ending. We thought when we started this that the hard bit would be getting the sensors to work and getting the numbers back to base. That was not the case. That bit turned out to be not easy, but not the really hard bit either. But more of that a little bit later. If you look at air quality, let's talk now. We want to look at these particles that are 2.5 microns in diameter. Fine. How do you detect these? Well, you use a freaking laser, which is awesome. And so you have this this laser diode here, which is firing out a thin beam, and then you have a photo diode looking through this lens, which is looking for twinkles. And when it sees a twinkle, it counts it. And on the back of this board is a big raft of processing, which takes the signals in from the detector and produces a reading. The heater there causes air to just to rise through. So it's all done by convection in this particular board. And you can pick one of these guys up for a £5, and they're fairly rubbish, but they do work. They do give you numbers. We're not too keen on the £5 ones. We like these guys. This is the SDS-011, which I think Steve must have one. I saw one of his devices was called SDS-011 on his thingamabob list. So it's out and about. It's a very nice device.
That's my initials.
Say again?
That's my initials.
Oh, okay. Amazing. There you go. That's me being too clever. This is you've got a sensor named after you, Steve. This is the Nova PM sensor, and about 15 quid will buy one. This thing here means you can plug it into your PC on a USB connection, or you can plug it into a microcontroller. Either work. They've been using these for quite a long time now all over Europe to get particle sensitive values, and they seem to work quite well. So that's the one we went for, and off we went with this thing. And so now we thought we'd build a device, and now I can kind of lean quite heavily on what Steve did in the first half, because we went down a very similar track. We went for the Arduino platform because it's dirt cheap and very powerful. We programmed it using the Arduino because when we started, MicroPython wasn't quite such a thing. And we used the ESP. This is the model of 8266 I quite like. It's made by Wemos. It's called the D1 Mini. These things about £5 a pop. That's where your PC plugs in, and that's the back of it. You can solder whatever you like on there. It supports. It'll work as an access point as well as a web server and everything else. So you can actually hang devices off this and use it to host a website. It's just insane what you can do for about £2.50. You can pick those up now on AliExpress if you don't mind waiting a month or so and having one or two out of 10 not working. Then you can get them for that kind of amazing price. This guy here is another one of my favorites. This is the ESP32, which is a bigger brother. This one is faster. It has a dual core processor, which is crackers, going at 240 megs. It costs around a £5. In this configuration, it has an OLED screen on it and a LoRa device on the back, which I'll talk about a bit more later. If I was making the call now between 8266 and ESP32, I'd go for the 32. Couple of reasons. It's got more processing grunt, and it also brings along Bluetooth BLE, which is rather nice and turns out to be extremely easy to use. I've got an ESP32 control in my Bluetooth BLE Furby, of all things, and it seems to work quite well. And the code to write it was quite easy. This guy's good to look at if you want to do super low power. The ESP32 itself has a sleep mode, which will take you down to less than 0.1 of a milliamp in terms of power consumption. And you can put it in that mode and make it wake up at a certain point in the future or when someone presses a button. And this guy's good because he also has power controls for lithium-ion battery. So you can bung that in the device. One of our tricks for making sensors that go out in the wild is a great big lead acid battery, which you put on a lamppost and wire one of these things in. And we reckon we can get about 100 days of battery life out of that because of the fact that the Fire Beetle will drop down to very low power. Lots of other devices claim that, but when you find that their USB circuitry takes a lot of current, they're not quite so good. So that's the one I recommend for low power. You can do shameless plug. So I wrote this thing about low power devices, and it's now in Hackspace magazine. Yay, go me. This is another trick for making low power stuff, which uses a clock. This thing here is a battery backed up real-time clock, and I'm using that to control the power switch via a MOSFET. So when it's turned off, it really is turned off. And you can use that to control Raspberry Pis and quite high current devices on a timer. So when the thing's turned off, the only thing taking power is the clock chip. And that has an onboard battery and it powers itself. And that was quite fun to make. So you can get all kinds of nice things like that. And you can program them in a variety of languages. I quite like C++. And so I'm using that from Visual Studio or Visual Studio Code. And there's lots of pre-built libraries for devices and services and things you can use for that. We've made some firmware we've called Monitor. If I turn my device on in configuration mode, it pops up as an access point. You can see it there. I can connect to that. It hosts a website. I can do my settings on there. And when it starts running, I can plug it into, I can put in my numbers and hit update, and it stores the Wi-Fi access point stuff. This is basically how Amazon Alexas are configured when you buy them. They host a website which you can then connect to, and then they get your settings from your entry onto that, put them in their battery backed up memory, and then off they go. So once I've configured it, I can then talk over a serial port to tell it what to watch, what it's doing, and watch it connect. And that's kind of like the basis of the firmware we're using in the sensors that we've got out there on lampposts at the moment. And you can make all this stuff, and you can make a very nice product that way. And it's also quite pleasing. This is version 0. This is my first proper sensor. This is known as the flower box sensor because the box has a flower on it. This was the breadboard, and then this was the real deal. There's my ESP32 in the middle. There's my clock. There's my GPS system, and there's my SDS sensor. And there's my BME 280, which is getting in my temperature, air pressure, and humidity. And this stuff, I think the entire kit inside here is about £40 worth of parts to make you quite a nice, compact little unit you can carry around and do things with. If you don't want to get all those frills and bits and pieces, then you can just get a single 8266 for about £2-3 and a sensor for about 15, and just use those and do it over Wi-Fi. That works. Yep. We're using Wi-Fi. We know the MQTT thing. By the way, it stands for Message Queue Telemetry Transport, which is a good thing to drop into your next pub conversation. If you want to pub conversations, what are they? When did we last have one of those? These are really old notes, Rob. Anyway, moving on.
That's what we're in now. We're in a virtual pub, essentially.
I'm on the water, me.
Oh dear.
MQTT is great. One thing which is really good about it is you can put MQTT server on your Pi. Take a look at Mosquito, and if you want to run around the house, that works really well. There's a thing called Node-RED, which you can get, which will let you visually wire up your MQTT signals and connect them to endpoints. It's great fun, and you've got it published and subscribed. So the broker sits in the middle. Sensors publish their numbers, and collectors subscribe. And these two things are nicely decoupled, and you can use them to push blocks of data around to do pretty much anything you like. I like using JSON strings because that way it's easy to understand. And there's a thing called PubSub client you can get. It's an Arduino library, which does all the heavy lifting for you. That works on 8266 and ESP32 and just works. It'll work to the Azure one on IoT Hub. It'll also work to the Raspberry Pi one you can run around the house. And they all work a treat. And this is the code I use to set it up. So I just say, here's my server, here's my port number, here's my method to call when you get something in of interest, and here's my please connect. This is my username, password, and device name. This is not particularly secure because there are versions of MQTT that don't use secure sockets, so anyone can eavesdrop and see your precious marrow temperatures, whatever it is, skidding around the network, which you might not want to do. If I want to send a message, well, I can publish. This is the topic, air quality data, and this is a buffer full of bytes that I can send to whoever wants to receive them. And any subscriber, there could be 1 subscriber, 10 subscribers, no subscribers, 100 subscribers. I could subscribe to air quality, and I get all the data then for everybody, or just to data or data/sensor99 and just get his sensors. You can do all kinds of fun things with wildcards as well to combine readings and stuff. And when in the endpoint, in my little 8266 device, I can subscribe to a topic, same thing. And when that topic gets a message, a method in my little program gets called inside my Arduino-based device. And I can then run and do stuff. I have to keep the connection alive by calling loop regularly, because every 9 seconds, a client says, hey, I'm still here. That's how it knows it's still there. The broker can then sort of tell you who's online and who's dropped dead recently. There are things called quality of service on MQTT. Level 0 is basically fire and forget. That's a text message. You've no idea whether it's got there or not. Level 1, it's guaranteed to get there, but the receiver might get multiple copies. And level 2, you get the message exactly once. IoT Hub uses level 2. And there's a thing called last wishes, where a device can say, if I drop dead, send this message to everybody that's listening to tell them that I'm no longer in the building. and then at that point they can sort of deal with that wherever they like. So this is all good stuff. PubSub client is good. Ellipse Paho is good. There's an MQTT client program for MicroPython, which I think it's called MQTT, which is quite nice. And then at the bottom, yeah, Node-RED is a good gig because that provides you with a nice thing. It's web powered. You host the Node-RED service on your device, then you can use it to wire things up. And it's great fun. It's good fun to play with. And you can put it into graphing and charting and all kinds of metering bits and pieces. Good to watch. So Azure IoT, this is basically what Steve said. You can use MQTT over Azure IoT Hub and it just works. It sits in the middle with the service bus, so you can basically hang what you like on the end, all over secure channels. This is the version of setting it up for MQTT. I won't go through that. It's just all there. I'll put these slides up on my blog, which is robmiles.com, by the way. I'm sure you're all reading it now. That's why everyone gone quiet. This is Steve used the portal, the Azure portal to control devices. And he also used the Visual Code. There is actually a freestanding app you can get called IoT Explorer. This is interesting because it's open source. So you can basically take this and rip off all the code in there if you want to make a freestanding IoT connection and client management hub. So you can write your own device registration and management and onboarding stuff if you want to make an entire workflow for your organization. So if you're doing 1 or 2 is fine via the portal. When I do 500, you want to write a program to do that, and you would steal this code and just nick its registration routines and then use those. That's what I do anyway. That's how I would do it. There's the code interface. This is what Steve showed you before. And there's a couple of live devices that I could talk to from within the IDE, which I think is awesome. And so, yeah, Azure Functions, yeah, these are lumps of code that run. Steve has already covered this. And that's you making a function application that is powered by an IoT hub trigger. There are other triggers, of which more a little bit later. And what my code does is it takes what comes in and lobs it into a storage table. And as Steve said earlier, we have a partition key, which is like a broad categorization, and a row key, which is unique for any partition key value. And these are crying out to be the device name for the partition key and the time the message was arrived as the row key. It's just such a nice way to do it. That's what I do. These are my readings coming in from my sensors. So I've got the device name, I've got temperature, humidity, air pressure, my 10 micron particle density, my 25 micron particle density, and a timestamp, which is basically a UTC number, all in JSON and all push into the server. So all I do is I make myself a plain old class with a bunch of attributes lobbed in to mark these things out. And then having done that, I then have this amount of code. And this is the code I use when IoT messages arrive, MQTT things come in. And that's my thing to say, whack it in a table. That's my name, is called data receiver. This is where it's coming from. All my devices, please. My connection strings in my little JSON file that tells me that. When the method runs, it goes, get me the bytes, make a new reading, and then use JSON convert populate object to take all those bytes and whack them in the result and then return it. And bam, that's it, 4 lines, and it's in the Azure table, which I really like. That's kind of cute. I think I'm, yeah, take it in slow-mo. It goes like this, followed by this, followed by this, followed by this. This SAS string is the thing which you make when you register the device, and then you've actually got the message that's coming in. You can log it if you want, but this code I haven't bothered. Get the bytes out, make an empty reading, fill it up, and then send it back, and away you go. And POCO stands for plain old C object, I think, which is quite a nice name. And there's the Explorer, which I was using earlier today with my air quality top hat. And you can see I was getting some numbers in that actually kind of, it doesn't have these guys, it only has the air quality. Something terrible happened there. I don't know what it was. I think if you ever have one of these things turned on and you start soldering things up, I could just put you off soldering like forever, because the thing lights up like a Christmas tree and the numbers go right through the roof, and you rush out and buy one of these fans. Because what with you liking breathing and all, although at my age, I'm okay. I use leaded solder as well. I've got nothing to worry about. Moving swiftly on. So yeah, this is my top hat. That's actually the picture of it. This is the real deal. And what this guy does is I can plug him in to the power and turn him on, and he'll wake up, and the lights around the side will come on, and he'll find the he'll basically start trogging around in a minute. Off he goes, and it'll start taking readings and displaying them. And if it yeah, that color is quite no. If once it's settled down, yellow is good, and then green is better, but red and purple are all over the place. This uses one of the sensors you've already seen with the lid off, and underneath that piece of black sticky tape is an ESP8266, remarkably like the ones in the earlier pictures, and that's actually doing all the heavy lifting. And so I can wear this and walk around and try and mainly to impress people, and sometimes it works. If I did some, it must be getting dusty in here because now the thing is waking up and changing colors. And that will run quite happily and display numbers. And with a bit of luck, they should have all gone into the table as well. But I'll keep moving forwards if that's okay, because I've got a few more slides to go at. Yeah, that's the guts of the device. I can say it's powered by Windows Phone because there's a lithium-ion battery there with Windows Phone written on the box, which I quite like. Controlling NeoPixels with these ESP devices is great fun. And these things, you can have a length of, well, you can get into the hundreds of them, and you can control them all individually. And there are lots of very nice libraries for doing that. I wrote one that makes them dance around the headband, which actually works quite well as well. So yeah, you've seen my quality, my hat, and there it is. And I want to move on at speed, if that's okay, to talk about LoRa and Azure, because LoRa is something that I think everyone should know about, because I think it might change the way quite a few things are done, and it's definitely worth knowing about. LoRa is actually LoRa, and it's low-powered radio, which is long range. That's what LoRa is all about. It's designed for things that have got battery life measured in years, and you can get LoRa transmitters that are cheap and very easy to add to devices. There are things about the size of a postage stamp, which you can now slap on devices. It uses a thing called spread spectrum technology. And so the messages are sent below the noise, which is a radio technique that's quite impressive, as packets of data. Think of it as SMS rather than a phone call or a video stream, and you'll be okay. The size of the message you can send is limited, and the number you can send in a given time is limited by convention in case you take up all the bandwidth. So these things have a stuff that sends data every now and then. Good news, the range can be up to 15 kilometers. And on a good day with a following wind and a friendly atmospheric conditions, you can go across continents. We've had people picking up things in Holland from the UK. If you've got flat land and almost line of sight, away you go. It runs on different wave bands around the world. We want 868 megahertz. This, in case you're interested, is a 433 megahertz device that Robert bought from China cheap, which is fine, but I can't use it in this country, so we'll put it away. Make sure you get the 868 ones. No license required, but if you're making a production-based device on this, make sure they're properly certified and that you don't breach the usage conditions. Otherwise, you might get people going after you. No one, as I'm aware, no one's ever been chased by people for being naughty on LoRa, but you don't want to be the first one, do you? Absolutely not. So you can think of it as peer-to-peer. So you can take two LoRa devices and you can push the data point to point. And so you could buy two LoRa devices and just send data up to 1 kilometer, small packets. And if you do have a greenhouse on your allotment that's outside Wi-Fi range, then this is awesome, because there's a good chance LoRa will get there. And you could send your marrow temperatures or whatever you like, that kind of distance, just point to point. And when one side squirts a message in, it'll pop out the other side. Now, this is effectively a broadcast that anyone with a LoRa device could pick up. So you may want to put some encryption and some addressing in there of your own, but it provides you with a nice little way of pushing bytes around over short distances, powered by 2 AA batteries. So it's good stuff. Oh, it got AA batteries right. That's really impressive. Sorry, I'm being distracted by my words coming back at me. So yeah, you can make it point to point. And so if you have an application that needs that, it will just work. But LoRaWAN is where it gets interesting, because you can make a wide area network using these devices. And each device within the application has a unique address, and is tied to a piece of endpoint hardware. Data between the endpoint and the hardware and the gateway is encrypted, and the gateway device forwards to a LoRa server that then pushes things onto your back end to make this wide area network thing. So let's track some cows because, well, why not? I've got some cows in the field. Here they are. I've only got one cow photograph, so you might say these are clone cows. Every now and then on the back of the cow, we have a GPS receiver and a battery and a LoRa device. And every now and then they push the cow's location to the air. And your LoRa gateway device picks that up and passes it over a network, and it could be GPRS, could be wired, could be Wi-Fi, to a LoRa server. And your back-end application binds to that to get messages when our cows report in, okay? And the idea is that I can have several gateways. I have one at top field, which is a farming term, meaning the field at the top, I do believe. And so this guy, being in the field in the middle, he'll be received by two gateways, this one and this one. And so what your LoRa server will pass onto your back end is a packet that says he was received with this signal strength at this gateway at this time, and this one at this one with this time. So you could do some primitive triangulation if you wanted to, but the idea is that that's all taken care of by this stuff here, and your back end server just picks up the data which you want to run your application with. So Farmer Giles has a map on his cow house wall or whatever with all the cows moving around, and you can do that kind of stuff. It's nice because the cows don't move that fast. The amount of data you're sending is very small, and you just send it every now and then, and away you go. It's very fire and forget. The gateway has a receiver for LoRa and a network connection, and this basically takes the messages in from the LoRa devices, your endpoints, and pushes them to the server. You can use endpoint devices themselves as primitive gateways, but a proper gateway has 8 receiving channels, whereas a little LoRa one has only 1 channel. The cheapest proper one's about 120 quid. It runs on Raspberry Pi, and you place these up high and outdoors. But the great thing about them is, what we're doing around Hull is we're putting these things all over the place, and anybody can use them, because the LoRa backend will take messages from different applications and different sensors and push them to the appropriate device receiver in the app end. So you just put these out once across a particular neighborhood, and then you can use LoRa for everything, because the Things network will do all the heavy lifting for you. This is an awesome enterprise. It's wonderful. It's all free, thingsnetwork.org. And basically they have, you buy your gateway, you put it on the Things network, and then anybody in the world can then use that if they come to your part of the country and get picked up. It just works. It's a way of building network communities. They've actually sell their own devices. You can buy their gateways and endpoints if you like, or you can buy cheap ones from China. But you buy your gateway, you put it on the Things network, and then you've got LoRa coverage for your area. And we've got one on the Humber Bridge, which is covering quite a large chunk of Hull. And we've got a few now around the town. So we've got reasonable coverage. We've also got commercial companies. Our local telecoms company and a few other people have also got LoRa gateways up there. So we have a trajectory planned where you could use open source to prove your thing is feasible. Then you can go on and buy someone with quality of service guarantees and a proper back end, which is guaranteed to be there all the time, pay them a fee per year and sell the service on for customers. You can do that if you like. So there are all kinds of ways you can do it. Most large cities are getting some LoRa presence now. Leeds, I think, is pretty good. Sheffield has a very active community. I'm not sure about Nottingham, but there's a map on the Things website on the gate which will show you where the gateways are, which you can take a look at. As far as Hull is concerned, this is Hull now. There's a 2 there, but there's also lots of other gates. There's 2 in there. There's also, this is a bit out of date. There's even more on there now. And there's the Humber Bridge one, which is doing quite a good job for us. The server is basically the back end that takes us. You can build your own server if you want, but we all use the Things network, which is free. So you register your gateways on this, you make your application on the Things network server, and then away you go. And you can start this by building your application, which has its own unique app key, which you can bake into a device, which you then deploy, or you can send these keys over the air. It's all encrypted. and the packets are very small. So it's actually quite secure. There's no such thing as a default password. You can actually burn things in before deploying them, or you can do this over the air activation. Either of those will work, depending on how many you're rolling out. I'm doing all ours by hand. This is what the data looks like. My sensors on lampposts are sending 1, 2, 3, 4, 5, 6 bytes of data, which has got the temperature, humidity, and then my pollution levels as well. There's a bit of code you can run on the server which unpicks that into a lump of JavaScript, which is a JSON, sorry, which is this bit here, and that then gets pushed into all the clients. So you can end-to-end this quite nicely, and then you've got this lump of data to do things with. This is the metadata I was talking about. This tells me when it was received, on which gateways saw it, and where the gateways are, and it gives you the RSSI signal strength number. So you've got a quite nice collection of data you can use to figure out what's going on with the information you're receiving, which is quite cute. And then what you do is you pump it somewhere else. So we use the data storage one, this chap here, but you can also, if you want, you can bind to a web request using HTTP integration. So you can push things that way, and you can basically put it into IFTT or KEIN for instrumentation and do things with it like that. We use this guy, which stores things for a week. And then there's a rather nice RESTful interface for pulling things back via a thing called Swagger, which is great fun. So you can just use a web request to bring all that back and then do whatever you like with it. If you want to, it's not likely I want to tell my cow anything. But so my cow tracker is one way. It'll just listen to where the cow is. But if I did want to push configuration data back, the way that LoRa works is to save battery, the LoRa receiver doesn't actually listen all the time. It listens for a few seconds after it's sent a message. So every time my cows send their location, they can then listen for a few seconds for commands back from the mothership, if you like. That's class A. Class B, I can make a device that listens every now and then. And class C, which you'd use for firmware updates and whatnot, is continued. But that one, you would not use battery powered devices on there. You just use, that's a powered device. These guys are the ones you'd use for your devices in the field. And if you want to use LoRa to Azure IoT Hub, then there's several ways you can do it. But one of the best ways is just to use the HTTP integration, which is this thing, which will then push a web request when a packet is received and then bind to it using the HTTP trigger in the Azure Functions. So what you get is a lump of JSON, which will then decode and put into your table and do what you like with. And in the message from the integration, you'll get a URL which you can hit against to push a message back into the LoRa remote device. So you can do both directions with this, and it works quite nicely. If you want to get really carried away, there's a thing called Azure IoT Central Device Bridge, which is an open source project for building this kind of stuff. And they have a site on GitHub where you can actually build out proper Azure services. And it's basically you press a button and the GitHub site will deploy all your IoT, your Azure IoT services and actually start doing things for you on that basis. One of the things about Azure, which is worth knowing as well, if you don't already, is that the free tier is pretty impressive. If you want to get just a small number of messages going through, then the free tier will actually do quite handily for that. And so you can actually get messages sent for nothing. And so don't forget that. This is us. What I'll do now is I'll just change what I'm sharing. How do I do this? If I go to my browser, which is, where's my browser? Huh. I think it's this guy. Yeah, here we go. So how do I change to it? Oh, here we go. This is my browser. And so this is me on, this is the Things Network. And if I go to my sensor map, this is what we're getting at the moment live. Can you all see this before? Everyone, can you see? Good. If I zoom in here, then this is what we've got. This is sensor number 3. And this has been sat on a lamppost for the last night. Oh, he's not. Here are his numbers coming in from, and it goes up and down a bit, and we quite like that. And what we do is we go and look at this chap. This chap here is actually not a physical sensor. He's the UK standard. He is basically the proper UK one. And if you look, he goes up and down about the same as ours do. So we're not really concerned with absolute values. We're more concerned with making sure that we're tracking the trends that the other sensors are seeing. And if I go around the area here, let's have a look at this chap up here. This is sensor, another one of our sensors. And he's gone quiet. Okay, we've not seen him for a while. Let's try this chap. He's gone quiet again. And as you can see, that there was that notch around 3 AM. And so we're quite intrigued by the fact that these numbers seem to track very well across our cheap little sensors. And this is sensor number 1. He has that notch as well. And what we were also trying to form opinions on is where the actual sensor, where the pollution comes from. And so we've got sensors out here as well. And what we'd like to do is take all these numbers and start trying to figure out when the thing starts to increase, which one goes up first, see if we can detect pollution coming in. And we had a lot of fun with this on Bonfire Night. Bonfire Night was hilarious. That was really quite impressive. But the whole basis of this is, if I go into here, these are my gateways. If I go into my applications, I can show you what the data looks like. These are all my sensors. I've got 15 devices up here. If I look at my data, I can see the messages coming in from the various lamppost-based sensors. That's my payload. That's my decoded value. If I go up here onto my world-famous blog, this is actually one of my sensors, sensor number 3 under test before we put one lamppost last year. And you can see there's the SDS sensor underneath at the bottom. There's my antenna. There's the actual Heltec device. There's my 3D printed curly pipe. And these are my two, that's the inlet. Sorry, that's the inlet and that's the outlet. I talked to the chap from Hull City Council about putting these lampposts. He said there's 2 things you have to know about these designs, Rob. Don't put a hole in the top and do put a hole in the bottom. So when it rains, the water goes straight through and drains out. Otherwise, it just fills up, which is bad. So we've had these things out on the lamppost now for nearly a year, actually, and they're still producing numbers. And the numbers, if I go back to my sensor map and we pull this chap up, it's cutting quite interesting in the light of COVID and everything else. If I go back to, say, 3 months and look, we can start to see that we've had ups and downs and it's gone kind of quiet, but now it's picking back up again. If I go further back, see if I can get a year's worth, see if I can get Bonfire Nighting. This Bonfire Night was quite impressive. But yeah, okay, need to wind back a bit more carefully with that. It went a bit nuts. The final thing I want to tell you about, though, which I've got to go back into here, so I've got to go into, oh, such professionalism, screen sharing, news share. I've got to go back to my slides, which is that one, please. Yeah, go down to the bottom. I want to talk about spider eggs finally, because you were promised spider eggs. And I'm not doing this terribly well, but I'll get there. How can your system be broken by spider eggs? Can I make that? I think I've got it. It's on my other side. Yeah, it's the resume slide. Boom. Yeah, okay. Can you still see that? I'll go to the next slide. That's my map. That's my summary. That's my spider eggs. Can you all see my spider eggs? Good. Yes. Right. Fine. My friend Robin, he had 2 sensors on his garden gate and he was reading them. And generally speaking, they were tracking quite well. That one was going up. This one's doing nothing. And he got quite worried about this because the numbers were all flat as a pancake. Why is this sensor broken? Because they've been tracking quite well up till then. So what happened was that he took a look in the pipe and eventually discovered that some spiders had laid some eggs in the pipe and blocked it. So up until now, he's getting no airflow at all. He kicked the spiders out. And suddenly, wow, we're back tracking again. And what we've found with this is that we get some readings, we learn a little bit, and then we get more questions. And one of the people that got involved and has an interesting viewpoint in this is Hull City Council's Air Quality Officer, who is a splendid fellow, but very concerned if we buy a £16 Japanese sensor from China, slap it on the lamppost, and then tell people the air around here is deadly and will kill you. And that was the thing he was more. So we've sort of learned a lot about how numbers work and what numbers actually mean. And it turns out that what you're not looking for absolute values. it's really weird. We're seeing this with COVID. Everyone wants to know whether 2 meters or 1 meter are actually the best values for social distancing. And the answer's really hard to come up with. And there probably isn't one, because a whole bunch of other factors is so important in that context that you can't really give a hard and fast ruling. But what we've found with this is that when you make numbers, that's one thing. When you make information that people can act on and it's reasonable to expect them to do that, that's quite different. So we've got sensors and we've got things that trend and things that track. And we think we can detect difference between when it's busy and when it's quiet. And there's lots of people when it's not. So we've got the fundamentals of kind of cracked. What we're trying to do now is figure out what the context is for our numbers and when we can start using them. And like I said at the start, that's not an easy problem. That's really hard, and it's not really technical, but it's very, very interesting. And that's kind of where I stop, I think. Yeah, it all goes back. I'll go back to the previous one, which is much more interesting. But I'll go to the summary. But yeah, we didn't know about spider eggs. We didn't know about any of that, and now we do. And we know how to upset people and how to not upset people, and who you should tell numbers to and who you should not tell numbers to. And never call them anything other than sensor readings. Don't say they're air quality numbers, because they're not. They're just numbers that are numbers of twinkles that a little sensor has seen based on what's gone into it. Fascinating stuff. Any questions?
Thank you very much, Rob. Awesome. That virtual clapping these days, it's not the same. Yeah, there we are. We have virtual claps. Very polite. I think Zoom is a lot more polite than it used to be. Certainly, if people want to talk over the top of you, they just mute themselves and can carry on talking. In a real meetup, people used to talk over the top of speakers and frustrate both the speaker and myself. So there is that. Although there are people that don't understand how to mute themselves, of course. So have you looked, you've spoken about, obviously, what's cracking off at the moment with COVID and the reduced traffic levels, and what are you seeing there? Is there a definite trend for better air quality?
Absolutely. I mean, the thing that the thing that I found interesting is that it all has trended. It actually has tracked, and in a fairly consistent way across. Although it's picking up back again now, so there has been a change. We want to do some more work. That's one of the things that we would like to get somebody in to do some proper data analysis of the numbers, because what the council has got some ins with some companies who do this kind of thing at a professional level, and one of the things they're intrigued by is how a cheap sensor on a pole can produce numbers that they can then put into their models in a useful way, and that's been kind of like a fun thing. But,
actionable data.
There's quite a lot of data now. We had the things up there. I mean, the other thing we're intrigued by is just how long these sensors will keep going, because they've been up there nigh on a year now, out in the rain and the cold and whatnot, and the numbers they come out with are still tracking the other devices, and so we should probably get one back in from the wild and compare it with a brand new one and see what the difference is and see how mucky they are inside.
Yeah, I mean, that's a really good point, is that the whole point of what they're doing is tracking dirty air, and I guess whatever they're sucking in to do that analysis will get stuck to whatever it is they're trying to.
I mean, we are careful with we only turn the fan on for a reading. These ones are fan powered. It's quite interesting because I was talking to the air quality man and I was saying, it seems that when the wind blows, it mixes the air around and the pollution goes down. And he said, no, that's rubbish. When the wind blows, a little fan in your sensor can't suck air in anymore. So no air goes in and the readings go down. And we said, oh, okay, I hadn't thought of that.
So you mentioned bonfire night is a really good example of when the air quality tends to go funny, and obviously all of the fireworks kicking out quite a lot. Is there any other times of the year that you notice? Barbecues,
and if anyone in the area has got a wood burning, people are buying these wood burning stoves. This is just, I'm sorry if you've got one. What, I'm gonna make a particle machine, and I'm gonna have it in my living room, and I'm gonna pay homage to it. I'm gonna burn wood in it. No. They're terrible for that, but yeah, barbecues definitely, but bonfire night, I mean, it's interesting that at the end of that, the spider eggs thing, that was around bonfire night, and you could watch it start to track up. But yes, for sure, those times. I mean, that's one of the things that you can bring home to people, is that you can kind of spot that kind of behavior. It makes a measurable difference. And what we have found is if you give someone a sensor and then let them start reading the values, they get very into this, and they look at them, yeah, so they quite like that. And so we've got we can produce kits of parts which we can and there's community-based initiatives. I think Sheffield's again a good place. They're doing quite a lot of this, putting kits in people's hands and making them build them and put them out there. And it does enough change your perspective when you see that number go up because of a thing you've done. Yeah.
I think Code Club are getting organised. I had an email from them a while back about a kit of parts for schools, and they wanted people in our position to be able to help with integrating that. That sounded quite good, but that was just before COVID, so I think that whole thing got put on hold. But obviously, yeah, you put any information, any data like that around where your children are, then that'll pique people's interests quite a lot, because obviously you have schools, but you also combine that with traffic to the school and from the school. And they tend to be high traffic areas, don't they?
Yeah, one of the things that we wanted to do, and we were in the process of putting together the local parish council in Cottingham, was get 5 or 10 system kits and get a bunch, build them in a day, and build them, and then compare all the numbers. And what the kids would find out is that all the numbers are different. And you have to go, okay, does that mean they're all broken? Does that mean one of them's broken? Does that mean that the air is different? And if you look at what you're doing, I think that that's a really good lesson for people to learn, that signal bar thing on your phone came from a reading from a sensor, but it's been massaged massively to give you that number of bars, because as soon as you're trying to use it, it just becomes zero. And so just the idea that these numbers come out of devices which are very fallible, and the numbers themselves are actually processed in quite an interesting way, would be a good thing to do. Getting people gathering data and trying to make sense of it is a good thing. Yep.
Has anybody else got any questions? I've monopolized the time.
It was a great session. Like I captured a lot of information that I could probably take a while to process. And wondering if, with regard to putting them on the lamppost, did you have to go through long, probably council-based paperwork?
Oh, yes. Very good point. Yeah, that was one of the hard bits. Was the council wanted us to give it some sensors that we had built. And so they said, okay, we'll give you a purchaser's contract. And we were basically a CIC, a company, community with no backing, no funds, just a bunch of men in sheds, really. And they gave us this 36-page contract and said, this is the contract we give our suppliers. And we said, well, that's hilarious. You know, we can't, this is not for people like us. So we had to find a form of words that worked with them in terms of approving what gets put on a lamppost, because if it falls off and hits someone on the head, there's a liability issue that comes up and gets you. And so, yeah, that was really hard work. That's one of the hardest things. In the end, we've actually got a form of words that worked for us. We went to see the people in Hull that put things on lampposts, talked through with them the design of what it should be and how to fix it. And then we effectively used their approvals process to get it up there and get it approved. But they're up there as prototypes. We can't really give them to them as products because they're not products. And we as a little community group aren't in a position to support them as products, but we still have to buy the boxes and pay the rent and keep the servers going. So yes, that was very difficult. And the project nearly foundered on that one because they just sort of, the council thought we could be treated as a normal supplier, and that's patently not the case. But they don't really have a terms of engagement for anything other than that. But we finessed that, and they've been up for a year now. And I'm pleased to say that they're all working still, and not one of them's fallen off. But yes, that was a major thing. If you factor in also the concerns of the formal air quality people, that we might come up with numbers that would scare the population. If someone stands underneath our sensor and has a cigarette, Does that mean that that area suddenly becomes dangerous to be in because of his fag smoke? Yes, well, probably it does. So we've had to sort of do all that. And I mean, the thing for me is I've learned a lot on the journey, as had everybody else, but we also now have a whole bunch of skills in terms of what we can do to get the next one out and take this thing further, which has been a lot of the value. But yes, you make a really good point. Just getting the thing out there on a lamppost is non-trivial. There was a whole bunch of hoops to jump through.
So you mentioned something about paying the rent. So you're paying the rent to the council to?
No, I mean things like we had to pay for the bits, and then there is a cost for the server backend stuff. The services that support our little. I mean, we've been talking to a local business group in Cottingham, who are very keen on commissioning some sensors to track stuff in our local area, and they are looking at a subscription model where they'll pay us a set amount per sensor per year, as it were, just so we can keep our servers. It's all hosted as a little Azure virtual machine running a Linux box, which has got all the code on it, because the guy that wrote all that lovely front end stuff likes Linux and has got it all running on that. I think it's all running inside. It's not Apache, it's one of the Apache variants with a little database behind it. But we have to keep that going. So he has to pay for that. But no, we're not renting the lamppost from the council. They paid us to put the things up, but they basically paid for the bits plus a little bit extra. And that was great fun. It was
very probably this is yeah. Just to sort of put in the point that Pete was bringing up, as an it kind of measures in 2.5 and other particles. How about probably from a perspective of when there's a lot of pollens in the air and stuff like that? Is it a kind of a mixed data, or do you see those kind of numbers kind of getting along with other numbers? Do you see some kind of a pattern?
I think that's a really good question. And the answer from me is we've not actually seen much that tracks pollen count. And the pollen particles, I think, are quite a bit bigger. Although, I mean, I think we've not seen, it is the biggest pollen we've had in that respect has been humidity. Because when the air is very humid, the particles swell up, and that can affect the readings in the device, which is why we have a humidity sensor in there. But in respect of pollen count, I mean, this is the trouble. You go around a corner and there's a whole PhD thesis to be written on this, whether using our data and local pollen data, if you can correlate based on other changes that you know are happening as well, some changes in the readings you're getting based on the fact there's more pollen about. So it's a darn good question, and I'd love for someone to spend 5 years finding the answer.
Yeah, thank you. Thanks a lot. It was kind of very knowledgeable to providing that thing. So I kind of assume that amount of time that you've poured over on this.
Oh, wait, not really. I know Matt's got a question, and I think your mic is working, Matt. Oh, no, mate. No, you were quite right. I can't hear you. That's a shame. Matt asked if you're putting your data into the sensor.community site, Rob.
We should do. We'll do that. If we're, our trouble is there's about 4 or 5 of us in the group, and we've all got other things to do as well. The guy that built the back end is doing a PhD in an allied field, which was nice. I'm myself and another guy are the ones that are keeping it going at the moment, and we don't have the bandwidth to do as much as I would like to move it forward. So yes, I'll look into that. Is the best answer I can give you. What we should do. We've got it all lying around. We should make use of it.
Hi Rob, this is Eleanor. I am going to be doing a talk on bin sensors next week. So
I saw that. I thought, oh, that's interesting.
So when you were talking about correlation between your air quality data and things like pollen count, we recently discussed a sort of correlation between looking at the bin sensor data against weather reports to see whether there is a correlation between the usage of your bins against how rainy it is or things like that as well. So it's interesting to kind of think, if we had multiple data sets, what that would all look like against each other, to see if we can see any interesting patterns. But I had a question on whether the sensors that you put up on the lamppost, like how high were they, and did you get any reports from the public of a suspicious object on a lamppost? Because we had, reports of something very suspicious in our bin. So, it was an interesting sort of engagement with the public on that part.
We had serious worries because we were concerned that people would nick them, and we were concerned that if the air quality man had an opinion on height, they ended up being about 12 foot off the ground, and they were fitted by the actual proper fitters from Hull Council. They have an arm that does this, and they were co-located with some professional sensors from another company, so that we were trying to decide if our readings and their readings would track. Now, as it turned out, they tracked quite well because we're both using fundamentally the same device to do the particle catching, but they don't light up. They're fairly anonymous, and I've not heard of anyone actually getting aerated. It was we were looking at lists of things to worry about, and that was on our list, but it seems to have passed off. We didn't label. We thought, shall we label these things? And then we thought, no, they're the ones that I showed you on my under test with a little spout sticking out, and they don't look like much, and they've been fine. I'm gobsmacked they're still working. It's been fun over the year watching them come on progressively better and better online as we've got more and more LoRa devices, LoRa gateways across the city, because that sensor one was very intermittently picked up at who we put some of the gateways in that area, and suddenly he came online big time. And so that's been the other thing which has been intriguing for us, is the idea that we now have effectively another utility for the area, which is if you want to make a device that can talk to the network back end, and you want it to be powered by a battery, and things like water level sensors in drains have been mentioned, PAX counters to see whether people are walking about, how busy gates are and things, put them on gates to see if footpaths are being used. You can do all that, and we've got a network backbone that'll actually support that in terms of the LoRa stuff. And anybody that wants to commercialize that, we have a trajectory involving Kingston Comms or Connexon or whatever, our local suppliers, so they can take it and make it into a professional level service. So it's been quite an interesting proving ground in that respect as well.
Sounds like a hookup with the traffic monitoring systems, where you see the pressure sensors across roads that get laid every now and again for people to be able to track.
Yeah, there's a thing in Hull that's called a Scoot system, I think it is, and they're talking about open sourcing that. They have an open data initiative which involves the Scoot stuff, I think, but they've also got things like car parking occupancy, and we may or may not, and again, this is it's a political thing, not a technical thing, we may or may not be putting our data on their platform as well, but there are a whole bunch of hoops to jump through on that one, because we don't want it to be viewed as official air quality data. The air quality man was telling me that he had this NO sensor on a road in Hull, measuring a tiny number of parts per million, basically in the noise. And one day that doubled. It went from one tiny thing to twice that. And he gets a phone call from the local newspaper and the BBC saying, this sensor value was doubled. Are we not going to die? And he said, that's what you're up against, folks. As soon as you see, and so if it goes from something very small to something very small, but twice as big, and everyone goes nuts. And that's whoa, that's when it gets kind of scary. So we have to watch that, but it would be great to tie all this together. It would be lovely, yes.
There's all sorts of cool stuff you can do indoors now as well. I mean, being MVPs, and three of us on this call are MVPs, Azure have got indoor mapping now as well. Have you seen that? So to be able to track air quality within a building as well would be quite cool, wouldn't it?
Yeah, if you use a sensor and cook a Sunday roast or burn the toast, if you have a sensor in your house, it will depress you massively. It's deeply scary. Like I said, soldering is incredibly dangerous, but yeah, burning the toast is very dangerous. Blowing out a candle is very dangerous. So yeah.
Don't put it anywhere near a toilet.
Moving on swiftly. It's amazing we're all still here, quite frankly.
Well, it's a very valid point though, isn't it? Because I know the government were looking at air quality in houses. Certainly when they started introducing double glazing and things like that, and the movement of air within houses is way less than it used to be. Obviously, we have warmer houses, but that's because the air isn't moving. We're not getting cold air coming in and replacing our stale hot air. So, I mean, I would have thought studying air quality in houses would be a really important thing to do.
Another PhD there.
Yeah, if you could make it affordable and cheap enough.
It's weird, as I say, you just end up with more questions. So yes, you have the thing on your desk, and then these numbers go up, and you go, I wonder why that is. Why has it suddenly gone up? You know, who's cooking? Who's making a pie? And it's yeah, interesting.
What did the dog eat? Or the cow, you know, whichever.
Indeed.
Really? Has anybody else got any other questions?
Yeah, I was wondering, Rob, how if you're getting anything in terms of reliability of the sensors. You mentioned that if you got 10 of them, all the numbers would be different. But are they reasonably within a sort of sensible range? I mean, how good are they, I guess, or how accurate are they, those ones?
I'm not massively. The accuracy is one thing. What I'm most interested in is watching them track up and down.
Yeah. So you rely on it. Sorry.
What we've found is that they track pretty well. What we did find with the SDS-011 is that we did have some devices that show what you call infant mortality, in that they broke or went nuts quite early on. But I'm looking for a piece of wood to touch. I can't see one around here. Everything's plastic. Touch wood. They're going all right at the moment. We did have a lot of concerns about how long they would last and whether they get bunged up and whatnot. But we put gauze over the holes to stop spiders getting in, which was a lesson we learned the hard way. And we've been quite careful on that side. And generally speaking, they track each other quite well. And the UK sensor, the one in the middle of hole, the proper professional one, quite well as well. So we've been fairly impressed by them. And that's been borne out by other people that have used them as well. I think the fan makes a big difference because you get a nice uniform airflow. Yeah.
Yeah, Ace. Do you have online source for design files for them? I mean, is it something that anyone can jump in and?
We do. It's on our GitHub site. I'll put it all up on the blog.
Yeah.
The code that's up there runs in a Heltec device. The most important part of the design file is there's a curvy pipe we use to connect the SDS to the elbows on the thing. Yeah. And that's been designed so that you can put it in anything you like just by, there's 2 bits of flexible tube that you cut to connect to each end of it. And if you use that, then you can put the sensor in any box you like. Right. And the boxes that we found were junction boxes from Amazon. But I've since found there's some quite nice ones in Screwfix, which will work quite well as well. They're a little bit cheaper and a bit smaller. Mm-hmm. But it's you can basically whack a sensor anywhere you like. One of our members has put a Stevenson screen, which he's put things in. One of the problems we have had is that the temperature sensor, with it being in the box, that's not very reliable, particularly in summer. In winter, it gets heated up by the rest of electronics. And in summer, it gets heated up by the outside, the sun shining on the box.
Right.
But we only really wanted the humidity. That was the thing we were concerned about there.
And do you have an idea in terms of what, I mean, so I imagine it would be interesting if you've got enough density of the sensors to see how sort of waves might appear as they go across as an event happens.
We have managed to see things go across, and you can watch the numbers go up. There've been 1 or 2 quite a big bunch of stuff came over from the Europe direction a while back, and we actually watched the numbers go up as that came over. I mean, that's the other big question: is you really like to know how much of the air quality is produced by way, locally, and how much of it gets blown in on the wind.
Yeah.
Because you can do lots of effort to reduce it where you are, but if you're downwind from if Scunthorpe fires up, for example, then what happens to us? The answer is everything goes up for us.
How long do you think it'll be before you can start correlating your air quality data to actual mortality and incidents in hospitals and stuff like that, if you even can?
My goodness, that's a leap. I'm not keen on that one. Well, I am
Really?
keen on that one, but I
Yeah.
think you'd have to have all the relevant data. I know we spoke to a guy at the university who's into the social side as well, and he was very interested in what we were doing. He'd have to feed it in as raw material to other inputs to his thesis. I think it's a bit like the early days of smoking, I think, when they thought it might be bad for you, but they weren't quite sure how. I think we've actually got to the point now where we do think that bad air quality is definitely bad for you in a way that leads to bad health outcomes. And so we've crossed that particular bridge. Now we're trying to figure out how bad and which things are the worst things to do, which is the next kind of level. We've leveled up from there. But it is, I think, the things that have happened over the last year or three have actually got people now thinking that poor air quality is a definite health issue that could affect me, my kids, and everybody else. And so I think whether you're ever going to map it down to individual people based on whether they've been smoking, what their job was, where they were, yada yada, is another thing.
But have you seen?
That's a bit of a big one.
Have you seen the COVID tracking app by that Zoe company? You laugh, but essentially it'd be the same thing. If you could get people to buy in to reporting symptoms of asthma and things like that as they go, if you could track that along with air quality.
Oh, I think that's. I thought you were going to mention the British government one, which of course is going to be world beating.
Yeah.
Let's not go there. But
yeah, unless you're on an iPhone.
Yeah.
Anything like that is a great idea. Anything on the health diary type of thing, because who knows what you could tease out by doing that.
All the data points you can get these days.
Yeah, I mean, a lot of it will be noisy, but you might get trends out of it, and trends are what you really want.
Yeah,
that's one
thing.
You
have to be careful of not correlating the wrong things, like you've just said.
Absolutely.
Yeah, it'd be interesting to see. I think with what's happening now, I think there's more chance of success with these models, because I think people are more interested in data and graphs and things like that than they probably ever were.
Yep, it's hoping. I think it's just human beings are really bad at risk. They basically see whatever risk they want. It's more dangerous to drive to the school than it is to go to it at the moment, based on, I think, whatever official health advice and whatnot. But it's not how we see it.
No. Eleanor, what are you tracking in your bins? I know we're kind of usurping next month's talk a little bit, but
we're tracking fill levels, and we're using the trends. So we're building trends and then predicting when they're going to be full, so that it's not a sensor that pings an alert and says, right, okay, I'm full now, you have to go and collect it. It becomes a full system where you'll get a collection list for that day for any bins that are predicted to be full, rather than just an alert. So we have a tendency now to kind of look at the data and see other things that we can pick up from it. So for example, tracking the difference between waste buildup in a city centre versus the outskirts, what that looked like at the beginning of the year, this year versus last year. And then we can also look at park usages. Again, we're kind of thinking along the lines of, okay, well, now that when the UK restrictions lifted, did we see that usage go up? Does that change if the day is raining? So we're kind of looking into the data and finding other interesting patterns. And also with sort of commercial buildings and the habits that they build when we start separating content types. So for example, if you get recycling waste, glass, food, general waste, we can begin to see as a unit what happens when, okay, well, the recycling bin filled up really quickly within a day, and then all of a sudden we saw all the other bins started filling up, and then we see a correlation in contamination as well. So it's being able to gather all this data and display it in a useful way to then report back and have somebody do something about it and trying to change the human behavior that creates this issue. And then also having a service based on data that is gathered over time. So we know that actually your bin shouldn't be collected on a Monday, it should be collected on a Wednesday because you had a delivery on X day. So yeah, it's been an interesting journey building the different kind of analysis models that we've been looking at and working with different sectors to see where our sensors can bring value.
Interested to correlate that data to advertising campaigns, and I don't just mean TV and radio. Obviously, you get advertising from the local council on social media saying, how we're going to collect bins on a certain day, or make sure you recycle your glass and things like that. It'd be interesting to know whether people see that in that data.
Yeah, I mean, we work very closely at the moment with Newcastle City, and they actually, I think, have the bin fill levels on a website. So when you can then report on a bin that's over full if you need to, but you can also see, okay, this bin that I want to report on is going to be serviced today. So there's an interaction there and an engagement in the community as well portion.
I suppose there's dangers in data as well, isn't there? Certainly that level of data where it could be, if it's household bin levels, is that the level of data you go down to, individual households? Or
no, so we don't currently do domestics because and that's been a question really, because we have yes. Absolutely. It's been a interesting question. Number one, because obviously we're very used to in this country, very used to what bin day is. Once that's ingrained, that's it. It's Thursday and it's black bin this week, it's blue bin next week. How do we then notify that actually, your next collection is due at this point? We need you to place your bins out, and then it becomes a different kind of service that needs real buy-in before it will work. Even with set schedules with commercial properties where they have to present the bins themselves, sometimes that doesn't even happen. So there's multiple levels of difficulty. But you are right, also in terms of actually tracking data on a property, you can then start being able to tell, okay, this person is in at this time or not in at this time, or they've gone on holiday clearly because for 2 weeks there's nothing in the bins, there's no trends building.
Or it's their birthday,
Yeah, I mean, around Christmas we see a lot of glass bins go up really quickly. So yeah, there's been a lot of interesting trends that we've been able to see.
Yeah, it's fascinating once you start measuring that sort of data. And I mean, Rob, where exactly are you putting your air quality sensors? And are they in residential areas as well? And
the council picked a whole bunch of places based on where they think it would have the numbers, and so then basically at road junctions, most of them. Mm-hmm. And but you can, precisely where you put them has a tremendous impact on what the numbers look like.
I love hearing this, because when we talk about bins as well, they're like, oh, we'll put it outside this thing, and then next thing you know, any shop fronts or specifically outside McDonald's as well, the bins are incredibly busy and the numbers look entirely different to just one that's 20 feet down the road.
Yeah, it's terrible, because you end up, as a person that's quite happy with technical stuff, because I can do that, you end up in all kinds of political and turf war type territory sometimes as well, in terms of where you put stuff. But no, they had a plan to compare our numbers with commercial devices, and just to see where we would go with that. And so they had the sites mapped out. They needed to have lampposts that had power that could actually drive the systems as well. That was an important thing for them. So we were just told, can you give us 4 sensors, please? And we said, yeah, we can do that. And so we made 4.
One of the companies that I'm doing some work for at the moment are looking at air quality. And one of the things they're thinking about is being able to ask people, or at least tell people where the air quality is bad, so that they can reroute themselves if they're driving. So they're talking about more of a, a countrywide based system where perhaps there's a particular amount of congestion in an area, and you could route around that so that you
So
might go
all
through
these
that.
cars that are causing pollution suddenly change direction away from one area to take their pollution somewhere else.
Yeah, well, you would hope that the amount of cars producing pollution would go down.
So you've got,
But
I think it spreads it out, I guess. It's, yeah.
maybe. It's interesting though. The data will be interesting. But you're one of many. This LoRa network of air quality measurement has been done all over the country, isn't it?
Yes, people are actually at it. I don't know what it was, but we thought we'd roll our own, because that way you learn more. And so we built our own stuff. But there's a couple of issues that are run across the country. There's a lot in Germany and the Netherlands as well. We just thought it was a fun thing that we were looking around for a thing to actually do. And we thought this would be a fun way of getting good with sensors and whatnot. And the council were quite keen. And so off we went.
So is this what Matt pointed out to earlier, the sensor.community community? Is that a way of tying all this data together? Is that what that's for?
I hope so. I'll look into it now.
I don't know anything about that. It is a shame that Matt's mic isn't working. Otherwise we could have chimed in, but yeah, it just seems like it'd be a wasted opportunity if there wasn't a central point where people working on this sort of community-based system could correlate data together and perhaps allow people who are really good at machine learning and analyzing data a chance at taking it and doing something practical with it. And likewise, exactly what Eleanor was doing, there's all sorts of data points that you could take and do things with. Cool. Has anybody else got any other questions? Silence. Obviously, you don't have to ask just Rob. Steve is still here. He's sat back, relaxing with his, I think you've got Corona or something. Or was it Sol or something? I'm not sure. It's Corona. Ah, nice. Topical.
Run out.
Oh, it's terrible. Me too, actually. I've run Australia. But all right, thank you very much to Rob and Steve. Two fantastic talks. Really enjoyed those. So round of applause, or virtual round of applause to both our speakers. And again, a reminder that we've got Eleanor here. I want to have Eleanor and Derek next month speaking about Tesla coils and smart bins. So they're going to be two fascinating talks as well. That's Thursday, June 16th, I want to say. So thank you to both of those for agreeing to talk as well. So do keep in touch. Obviously, feel free to tweet. I said NotsIoT. If you've tweeted on the hashtag NotsIoT, I'll go through the tweets and put those ones into a little stupid HTML prize picker online that I've got. And somebody will win a JetBrains license. So thank you to JetBrains for sponsoring. And yeah, thanks to everybody for coming, and keep in touch, and we'll see you again soon. All right. Thanks everybody for coming.
Thank you, everyone. Thank you, Rob. Thank you, Steve.
Thank you very much, everyone. That's fantastic.
Brilliant. Thanks for coming.
Yeah, thank you very much, everyone.
Cheers.
Next time. Bye.
See you again soon. Thank you.